Video, we're going to be looking at examples 20 and 21 of applications of differentiation. This is the extension questions. Like last video, just make sure you've done lesson 8, you've done lots of optimization questions before you get into these because they're harder. Now, example 20 before made no sense to me. I was working at it and I'm like, don't know how to make this work because it's a triangular enclosure and you have the restraints of Pythagoras also, so I just thought, no, scrap it. I wrote a new question here. Now, don't worry, it's still to do with farmers. So a farmer is making a planter garden bed. So that's like one of those raised planter beds. And he has 6 meters of corrugated steel. Now, this corrugated steel is like yay high, but 6 meters of it. Now, he wants to curve that corrugated steel to make it into a planter and wants to know what is the best shape to choose to maximize the total area of the bed. Okay, now the shape that he wants to make is rectangular with a circular ends, just like that. Okay, and it's pretty cool what happens here. So first thing, let's represent this using a diagram. These are the straight bits, and this is the circular bits there. They're saying as well that they want the width of this to be X and the straight edges, the side, to be Y. So let's generate some equations. We can see that the perimeter of this is going to be 6 meters, and the perimeter is made up of 2 straight edges, which is 2y, plus you've got this bit here and there. Now, if you add them all up, that's the circumference of a circle, 2 pi, right? Then half of x. What comes out? Quite nice. Now that there is equation 1. Now I'm just going to change that color just so it looks a little bit different from the rest. Okay, now what we're going to do next is we're going to try to maximize the area. So let's generate an equation for the area. Well, we've got 2 semicircles here, so in total that's 1 full circle. So we can say that's pi x on 2 squared, don't forget the radius, plus the area of that rectangle, which is xy. Let's expand that, and you've got pi on 4 x squared plus xy. Let's call that equation 2. Now we can see we can't maximize equation 2 until we've rearranged equation 1. Now, one thing I omitted was I was meant to put 6 there because that's like the amount of metal that he has. Let's rearrange equation 1 to swap out that pesky y. So here we go. So there we go, y is equal to 3 minus pi on 2x. We just divide it all by 2. Now let's sub that into our equation there for area. Okay, now let's expand that. And bring them all together. Now we can see pi on 4, take pi on 2 becomes negative pi on 4, x squared plus 3x. So now we've got equation 4. Let's now optimize this. So to optimize, we want to maximize, so we want to differentiate and find those stationary points. So dA dx okay, so we've got that there, and then we make it equal to 0. Times by 2, divide by pi, and there we go. You've just found the diameter of the semicircle part, 6 on pi. Okay, now our next step is we want to work out the dimensions of this garden bed. We know this is going to be a maximum because it's a negative parabola. So our next step is just to simply find what y is and then what the area is. So let's find out what the area is firstly. Okay, and we can use our equation. Where is it? Equation 4. Okay. Now you may note I'm doing this all in calculator. Sometimes they can ask you this in non-calc as well, in calculator as well. And so, sorry, I'm just doing two things at once here. There we go. And so you might just use a class pad for all this stuff, but at the moment we're going to practice just doing non-calc. Pi's cancel, it's negative, so it's going to be negative 9 on pi plus 18 on pi. Our answer, 9 on pi centimeters squared. Now this is all exact. You can put this into your calculator if you want and confirm all these. So this corresponds to 2.86 centimeters. Oh, sorry, I said centimeters, I meant meters squared. Meters squared. We've got our area. Now let's find out our y. Now I really like this bit. Let's find the y. Now remember the y represents the straight edges. Now we've got an equation for y already in terms of x, equation 3. So that's what we're going to use here. Y is equal to 3 minus pi on 2 times by x. X is 6 on pi. 3 minus, they cancel, so it's 3, which is 0. So y is equal to 0. Well, let's have a look at the situation. We know that x is equal to 6 on pi and y is equal to 0. What kind of shape is that going to make? Well, we can see that those straight edges, if they go to 0, the two semicircles come together and you actually make a circular garden bed. Okay, so we've just made a circular garden bed because y is equal to 0, and the diameter of this thing is going to be 6 on pi meters. Okay, and that has a circumference of 6 meters of corrugated iron used, or steel I should say, and the area of this is 9 on pi meters squared. Pretty amazing that, and it sort of just shows that when you're maximizing areas, an even better shape than a rectangle, a rectangle tends to a square, an even better shape is a circle. Circle is fully optimizes the amount of area that you're given for its dimensions. In this video, we're going to be looking at example 21. So a closed cylinder of height h centimeters has a base with radius r centimeters and a surface area equal to 30 centimeters. What should the height and radius be if the volume of the cylinder needs to be maximized? So first thing here, it's asking for surface area. You may remember unfurling the net of a cylinder in year 10. You got two circles, and then this was h, and this was 2 pi r between here and here. So therefore that's 2 pi rh. So surface area is equal to 2 pi r squared plus 2 pi rh. Next step is we've got to sub in. We know that the surface area is 30. So there we go. And let's call that equation 1. Now we're trying to optimize maximize the volume here. So let's find the volume of this, pi r squared h. And that's equation 2. And we can see here that we need to get rid of that h. So let's see if we can swap it out. Rearranging equation 1, 30 minus 2 pi r squared is equal to 2 pi rh. Let's just swap sides because we normally like having h on the left. Now, what we want to do is get rid of these 2 pi r's. So we'll divide every term by 2 pi r. We can see that that r just disappears. Now, I like to do this. I like to bring up my r as a negative there. Just makes, usually in calculus, it makes it a bit easier. Got equation 3. Now let's sub that into our volume equation above and get rid of that h. Expand. So this one becomes 15r take pi r cubed. And this is our volume equation. Now you can always just, use a few more steps there. If you found that tricky, that's absolutely fine. And so this is our volume equation. We want to optimize this, so let's differentiate. Make it equal 0 to find that maximum point. And we can see that the answer is the square root of 5 on pi. So we've got that 1.26 centimeters. You can use it to 4 decimal places if you want a bit more accuracy as well. So now that we've got R, we're on the home stretch. We just need to work out the volume of that cylinder, but also the height of the cylinder. Let's work out the volume first. Volume, plug into our formula, and we've got the formula there. 15 lots of 5 on R, take pi 5 on pi, all cubed, and we can put that into a calculator and out pops 12.62 centimeters cubed. We can also have a look at the height. The height is equal to, and you're just plugging into that formula again. And this is okay to put into a class pad because it's just a fair bit of work. And the height comes out to 2.52 centimeters. Now, interesting note, you may see that if I double the radius, it makes the height. So the diameter of the base is also the height. So it's trying to optimize this thing, and it's trying to make it as basically as robust as possible. So this is a classic thing we do when we're trying to maximize the volume. So there we go. Hope this video was useful. And that's it for lesson 9. Have a go at exercise 6D. Try as many questions as you can here. If you find these all hard, I'd be going back to 6C, trying lots of questions there, and then moving back to 6D, because these aren't so straightforward. And yeah, you sort of have to work up to these questions. Thank you, and hopefully you found this video useful.